Hey everybody. Today I wanted to show you how to solve a system of equations using matrices, which is a really powerful and speedy way to do it. You will need a calculator for this, a graphing calculator that can use matrices, but that shouldn't be a problem, should it? The first step you'll need to do in each case is to write the equations in standard form, which means all the variables are on one side. The numbers are on the other side, and more than that, the variables will need to be in the same order in each equation. So in our case, w's, x's, y's, z's. If anything's missing, you'll just have a gap in that particular equation. That happens sometimes. If you can do that, then what you'll do is you'll take all the coefficients, the numbers in front of each of those variables, and write them in a 4x4 square coefficients matrix. Typically we give that coefficients matrix the name A. If there are any terms missing, then you'll have to include a 0. You'll see that come up. After that, you'll take and write a column matrix, in our case a 4x1 column matrix, which we often give the name x to. That is of the variables. Then you'll take the totals on the other side and make a column matrix out of those. And at this point, you'll have to get out your calculator and you'll put the first A matrix of numbers in. You'll take the second matrix, or the last matrix we made, the totals matrix, and type that in to matrix B, and I'll show you how to do that in a minute. And as soon as you're done with that, the total is a single calculation, which is equal to A inverse, which is the -1 looking like button on most calculators, B. So really simple little calculation, A inverse B. So let's see how that works in an example. So, oops, stay put guy. There we go. So here's a example, a 4x4 system of equations. And the first thing we're going to need to do is put each of these equations into standard form. And so if we look at this first example, w minus 3x plus y equals 4z. It's almost in standard form already, except for those z's are on the wrong side. And so I'll just subtract 4z's from both sides and write it as w minus 3x's plus 1y minus 4z's. Sorry, my handwriting's a little bit awful here. Is equal to, and then there's nothing left on that side, so we'll put a 0 as the total on the other side. In our next equation, x's, y's, number, there are 3 w's. Those are already on the right side. Our x's from the right-hand side, or right-hand side, should come over to the left side, so I'll subtract an x from both sides. The y's should be subtracted over here as well, so I'll write minus 2y's. The z's are already on the right side, so we'll just write them again, minus 6z. And there was no total, so that's equals 0 again. And then for our last equation, z plus 2x minus y equals 1, that's almost in standard form already. All the letters are on the right side, and the numbers on the right side. We just need to put them in order and maybe leave a gap for the w's. And so let's write that as no w's plus 2 x's and minus a y plus a z equals 1. Now that we have our equations in standard form, we're ready to set up our matrices. And so let's begin by making a 4x4 matrix of the coefficients in each one. This is the matrix that we typically call A. So we'll write matrix A, and it will be a 4x4 table of numbers, which is just the numbers in front of each of the letters. And so in our first equation up there, we've got a 1w, we've got a minus 3x, we've got a 1y, and a minus 4z. In our second equation, we've got no w's, which will be important that we put a 0 there, and we've got 4 x's, and we've got 1y, and a negative 1z. In our third equation, we've got a 3w, and a negative 1x, and a negative 2y, and a negative 6z. And in our final equation, once again, there's no w's, so we'll put a 0 there. And there's 2 x's, negative 1y, and 1z. So that's our coefficients matrix. The next matrix we need to set up is our variables matrix, and that will be a 4x1 column matrix that we'll call X generally. And these will be the letters, but in order from left to right. I can't really explain in a few minutes how matrix multiplication works and why we have to do a column matrix instead of a row matrix. I admit that probably would make more sense to have our letters in a row just like they show up in the equations, but this is how it is. If you want to learn more about that, I'd encourage you to look up matrix multiplication. Finally, we need to set up our variables matrix at the end, or excuse me, our totals matrix, which we typically call B. And so I'll say B here, a little equal sign. And this is the totals from the right-hand side. And so we've got a 0, a 17, a 0, and a 1. And so these then are the equations that will be putting into our calculator in just a minute. So let me grab a calculator. So if we want to type this into our calculator, we'll turn it on, and there's a matrix button right here. It's you'd have to press second matrix to get it on. And I've already got a couple matrices already in here, but we will edit matrix A, and first thing we'll want to do after we hit edit is to change its dimensions. We want A to be a 4x4 matrix, and so we'll just type that in there, and then we will hit type in our numbers and hit enter each time, and it will go kind of from left to right and down the page as we type in these. So we have 1 and negative 3, 1 and negative 4, 0, 4, 1, and negative 1, 3, negative 1, negative 2, and negative 6, and finally 0, 2, negative 1, and 1. So there's our first matrix. I'm going to quit out of this, so second quit, and go back into the matrix menu. You can see it's stored in there. It's a 4x4 matrix. Now I'll edit matrix B, and this one is a 4x1 matrix. And I'll type in our new values, so 0, 17, 0, and 1. And once again, when you're all done, quit, get out of this. And to bring up a matrix, you can type in second matrix and hit enter or select this one. If I just hit enter right now, you'll see that that matrix pops up again. You could double that matrix if you wanted to for whatever reason, and you see that every number gets doubled and so forth. So you can do all sorts of different math with matrices. The math that we're interested in today is to multiply A inverse by B. And so we'll type second matrix A. We'll press this little inverse button. And then again, second matrix, and come down to B. And if we hit enter, notice how it gives us a column matrix here, 7, 3, 6, 1. 7, 3, 6, 1 is the answer eventually. I'll transfer that onto our page here. So our variable matrix W, X, Y, and Z is equivalent to this matrix we just calculated, 7, 3, 6, 1, which means that W is equal to 7, X is equal to 3, Y is equal to 6, and Z is equal to 1, which was extremely fast and speedy and didn't require us to do any sorts of substitution or elimination or anything. Again, just a little bit of rearranging and some work on our calculator. So how cool is that? Anyhow, hope you enjoyed this video, and I would encourage you to give it a try.